So I had a few questions about my previous video on the Ryobi 40 volt battery packs. One of the questions was on the double FET, if there's another way, if you could just jump across so that you don't need the resistor, if you could just jump. And you can jump from this spot to this spot here. If you were to run just a wire from there to there, you'd basically bypass these two FETs. These FETs are basically like switches. They switch on and off depending on what the circuit is determining, and basically they're safety switches. You don't really want to bypass those. I don't recommend bypassing it. They are trying to prevent you from overcharging or over discharging your battery pack. So of course do this at your own risk, but you could on the dual FET pack from this point to this point, this whole area here and this whole area here is what you want to jump across. So you could jumper a wire there, and on the single FET pack it's even easier. You could jump from this one here to that one, so you could just run a solder bridge probably across there. Like I said, I don't recommend this, but if you know what you're doing, do it at your own risk. Like I said, they are there to protect you. There's on the battery pack, the circuitry here has this is a temperature sensor. There's one here, and there's actually another one in by the FETs here. And so it's monitoring the temperature, and if something exceeds a certain temperature, then it's going to shut down the pack for you to protect you. What you should do is you should definitely check your individual cells on your pack. So if we look at this battery, if I measure from the ground here to the positive, we have 18 volts. Move that over a little bit so you can see that better. So we have 18, almost 19 volts there. But if we measure across the individual cell packs, you can measure from the CL1 minus to CL1 plus. So this is your negative point, or this is your negative point too. It's all the same. From here to here, you notice I get, 2.8 volts. And if I go to the next one, I should be switching the leads, but I'm just going to go across this way. So it's going to go positive, negative, positive, negative. So this one here again is positive 2.8. So if I go to this from here to here, I'll get -3. So there's a little bit of difference in the cells, not too bad. Go to the next one, 3.1 volts. Still not too bad, but when we go to the next one, you notice it's less than, well, it's pretty much 0 volts. If I take this rate off, it's actually higher. So, and the next battery here, again, 0 volts. And I have tried charging this pack a little bit. I haven't tried charging it right up, because when I charge these packs up, I charge them up. I'll hook up a small voltage to the packs from the ground to here. I'll hook up, say, 10 volts to it, and then I'll monitor the individual cells to see if there's any cells that aren't rising, because this pack was completely dead. All the cells were at 0 volts. Generally, you don't want these cells to go to 0, but this one was at 0. I thought I'd try and charge it up to see what happens, and as I started charging it, I noticed that these ones were going up, and they seem to be staying up. Oops, from there to there, -3 volts, +3 volts, and then we drop down to 0 volts. So there's obviously something wrong with this set of cells and this set of cells. And you see I've already marked this one with an F for funky. So another way you can do this quickly to check there's basically two 10 volt packs in here, and you can go from the ground here to the fuse, which is over here, and we can check that voltage. So this voltage here is 18 volts, so half of 18, 9 and a bit. So if we go to here, we should have 9 volts. And if we go here, 9 volts. So it looks like they're, well, actually I should be going this way for the polarity, but So it looks like this pack has 9 volts here and 9 volts here. So it looks like it's kind of charging properly. But when you start checking the individual cells, we see that the cells here are dead. And if we check across the top here, there's one cell in here that's questionable too. That one's good. That one has like a quarter of a volt, but the cells beside it are at least at 2.5 volts. So this pack here, I would definitely not try and charge the entire pack. This pack would probably, I would take it apart, try to salvage the individual cells. And the way that I do that is by unsoldering all these points where the CL is, CL plus, CL minus, all these points. So there's points here and then there's points here. And when I show you what it looks like without that circuit board on top, this is what you get. So these are those points. And like I said, this is a 1 cell pack. So if we go across here, it should be 10 volts. Sorry, 20 volts. And if we go across here, it should be 20 volts as well. And then the 2 cell packs put together with that fuse in here. And that fuse is this fuse right there. That's a fuse, fusible link. So that's basically fusing these two together. So if we were to put a jumper across here and go from here to here, we would have 40 volts if the battery pack is fully charged and everything's working properly. Actually, it could be as high as 42 volts. So that's what the pack looks like without the circuit board on top. So this circuit board is just mounted on top of there. So unsoldered all those points, and I removed this pack because this pack I believe has something wrong with it as well. So I'm going to salvage the cells in here that are good and discard or recycle the cells that aren't good. One other thing I should mention is that even though this battery pack is only partially charged, if we push the button here, you'll see all 4 of these lights light up for like half a second, and then it goes down to 2 lights. I think that these different lighting sequences are indicating a specific fault with the pack. And so even though it shows momentarily, it shows up to all 4 lights, it's definitely not charged. It's not fully charged. Each one of these should be 20 volts, but like I showed you, this is 9 volts, this is 9 volts. There's some dead cells in each pack here, and so it's throwing up a fault code. And that's why the circuit board has shut down those 2 FETs, is because there's something definitely wrong with this pack. So you can't salvage this pack as is. You have to remove the individual cells to salvage them. Here's another pack that has 2 bars. If we look at it, it shows 2 bars. And if we measure across from the absolute negative to the absolute positive, here we get pretty much a constant 38.25. But if we go across here, it's not measuring the right voltage, and you can see it's actually dropping. We know that the battery pack isn't actually dropping, it's just not measuring correctly. And that's because one of these FETs is probably either switching off or it's not on properly, and there's not enough load on here for it to actually, it's not allowing the pack to discharge. So what we can do is put a load across here and then measure it with a load. You want a small load. Usually what I use is, this is a 2 ohm resistor that I'll use to sometimes load up my packs to test them. This would be considered a big load. It's going to draw 10 amps from the pack. You don't necessarily need something like that just to activate the FETs to make sure that they're both on. So if we measure across here, 33 volts, keeps going down. So to test a battery with the cover on, and I want to check across these to see what the voltage is, you need to put a load on. And what I use for load is a 100 watt incandescent bulb. And what that allows me to do is it'll draw some power from the pack. I've just hooked up a couple of alligator clips here, and I'll put one on here. And as soon as I hook this up, you'll see this light bulb light. doesn't glow really bright, but it's producing a draw on the battery, and so those FETs are turning on. And if I measure the voltage, this other alligator clip goes to the, should go to the positive. So that's going to the positive of my meter. I've got my negative here. So if we measure the voltage on here, because I just activated the FETs with the light bulb, it's showing closer to the correct voltage, or actually the correct voltage, but eventually that will start to drop again. It's about a minute that it takes before it'll start dropping. So it's like the circuit turns on the FET, and then after a minute, if there's not enough significant amount of power drawn, then it shuts off the FET, I guess to save power. I'm not sure why. But after about a minute, we should see those numbers start to drop. And there they go. And so when you first pull your pack out of your tool, you could pull it out and quickly try and test those. You might get an accurate reading, but a better way is, or just another way is to take a load, like I said, this 100-watt bulb. We'll hook it up, and now when we check it, we're measuring a more accurate voltage. That's without the load. Again, that's the actual voltage of the battery. And then with the small load on there, it's going to drop a little bit. So it gives you a better idea of what the voltage is of your battery pack. So I should also point out that with this 100-watt light bulb, the current draw is only about 0.5 amp. So it's not a very big load. It's enough to safely pull from this pack without discharging it too much and activating those FETs to be turned on. So another observation that I made is that some of the battery packs, when I've done that resistor mod, don't actually charge when you hook up power to these two things. There seems to be two boards that look identical, and the only thing that I can figure is different on them is the software on these chips over here. So the software on them is different, and it seems like this one here is, if you look down here, it's got a date code, December 17th, 2013, and it also has this other number in black, 018. I'm thinking that that's maybe a version number of the software on here, and anything with 18 doesn't seem to work with that resistor mod. The other ones that I noticed that it did work on was version 14. So that works with these ones. Another way that you can tell, or another way that I noticed, was the color of the batteries. So if you look at this one here, can we get that to focus? This one's 14, right there. And this one's 18. Right there. So the other way you can probably tell is you've noticed that the batteries are a different color. So when they changed the batteries to these batteries have a slightly higher capacity. These batteries are the 95 watt. So if we look at the back of the battery, the ones with the light green are the 95 watt. The ones with the darker green are the 93.6 watt hour. So if you're having problems with that resistor mod working, it may be because the software is different on the different boards. So the last thing I wanted to cover was the battery charger itself. This is a newer style battery charger. Some of you may have the bigger, bulkier battery chargers. With that resistor mod, I was able to get this battery charger to charge the battery, but like I said, it depends on the software version, and possibly even if the cells are way out of balance, it may not allow the battery to work at all. So check your battery individual cells like I showed you. The other thing that I use for charging my battery packs, you may have seen in my previous video, was This is a little boost converter, so you can hook up 12 volts to one end. So on the input end, I just put a jack there, and I connected to a laptop power supply, and I'm able to power this. And then you have your positive and negative out, of course, and then you have two adjustments here. The two adjustments are constant voltage and constant current out, and that'll change a little bit depending on the load. So if you're trying to charge a battery pack that's really low, voltage won't be very high, so the current will be really high, even though you've got it set for your other battery packs that are closer to 40 volts. You've got it set to kind of max out the current at 1 amp. When you try using this to charge a battery pack that is really low or possibly even dead, the current will be really high because the voltage will be really low. So it can only compensate so much, but as long as it's close, you know, you have a little bit of leeway there, and it's kind of nice. So there's a little LED here that changes from red to green once it's reached its final voltage. But you have to play with these and get them set pretty close to where they need to be. And like I said, you always want to be monitoring your batteries when you're charging them, checking for see if all the individual cells are charging properly, and that the voltage is not getting too high when you're charging, and then things aren't getting too hot and you're not going to have a fire. So I think that I've answered all the questions. If you have any other questions, leave a comment below and I'll try to answer them, possibly make another video if I have enough questions. And please like and subscribe, and more people that like and subscribe encourages me to do more. Thank you.